Hi everybody, welcome to Science with Sudeep. Today we're going to discuss about vector addition. There are two types of vector addition. One is head to tail vector addition. The other one is tail to tail vector addition. Please see what's a vector. A vector has both magnitude and direction. And a vector is a physical quantity. It must have both magnitude and direction. It must have both magnitude and direction. How do we represent a vector? That's very important. A vector is represented by an arrow. The length of the arrow shows its magnitude. The arrowhead shows direction. So this vector is heading towards east, or you can say it's heading towards right. There are two types of vector addition. One is tail to head vector addition. Second one is tail to tail vector addition. These are the two types of vector addition. Let's first see what is tail to head vector addition. The keywords are tail to head. For vector addition, there should be at least two vectors. If we have a vector, the first vector, let's say it's f1, that's our first vector. And if the second vector is f2, the vector addition, if the two vectors are in one dimension or in a straight line, we can do like this: f1 plus f2 give the magnitude of the resultant vector. This is the mathematical representation of vector addition. So it shows that to get the resultant vector, you add two vectors. So now I'm going to draw a vector. This vector shows f1. It's a vector which is towards east. Another vector f2 which is heading towards east. Both vectors have the same direction. Let's see how you add these vectors by tail to head vector addition. You draw the first vector, which is f1 here, and the vector has a tail and a head. This is the head of the vector and this is the tail of the vector. You take the second vector. The rule of vector says that you can place a vector anywhere by kept the direction and magnitude same. So you can move this vector from here in such a way that the tail of this vector touch the head of the first vector. That's why it got the name tail to head vector addition. You place this vector in such a way that the tail of the second vector connect the head of the first vector. This is tail to head vector addition. And what's the resultant vector of this? Resultant vector of tail to head vector addition is, it's a single vector which drawn from the tail of the first vector to the head of the second vector. That's a resultant vector. So resultant vector of tail to head vector addition is a single vector which drawn from the tail of the first vector to the head of the second vector. What is actually a resultant vector? We must know the definition of resultant vector. As I said, resultant vector is a single vector which is the sum of two or more vectors. That's actually a resultant vector. So this vector in green color, this is a resultant vector, and direction of the resultant vector is very important. If you know the magnitude of the vector f1, let's say it's equal to 2 Newton, and f2 equals 3 Newton, the resultant vector must be 2 Newton plus 3 Newton, you will get 5 Newton. If you substitute these values in the mathematical formula, you can see that your f1 is 2, your f2 is 3, and you will get 5 Newton. So if the question is calculate the resultant vector by drawing, you must follow this method. Calculate the resultant vector by mathematical method, you must follow this method. Let me show you how to calculate resultant vector in tail to head method, in graphical method. Let's say the question says that your vector f1 is, this question number 1, vector f1 is like 2 Newton, f2 is 3 Newton. The question is calculate the resultant vector. That's the question. So how are we gonna do that? The first step is step number 1. Must find a suitable scale. That is the first step. You must find a suitable scale. This value, this is actually magnitude of force, 2 Newton, 3 Newton. It's not there in your ruler. You can't find 2 Newton or 3 Newton in your ruler. So you have to convert, or you have to find a suitable scale which you can use in the ruler. So in the ruler you have, the units you will find in ruler is centimeters or millimeters. And we know that 10 millimeter is equal to 1 centimeter. We know that. So let me find a suitable scale for this question. The scale I'm going to choose, my scale is 1 Newton equals 1 centimeter equals 10 millimeters. You can either use 1 Newton as 10 millimeter or 1 Newton as 1 centimeter. If you take that scale, you know that, if you take that scale, you know that your 2 Newton is equal to 2 centimeters or equal to 20 millimeters. Then your 3 Newton is equal to 3 centimeter equals to 30 millimeters. That's the scale we're going to use. Then you take a ruler and measure from 0 to 2. See, let's say this is 2 centimeter. We have to write here, this is vector f1, which is actually 2 Newton, but the scale we use here is 20 millimeters or 2 centimeters. Then you take your second vector and we are following the tail to head vector addition. You place the tail of the second vector on top of the head. Then you draw that second vector, which is 3 centimeter or 30 millimeters, 3 centimeters, which is your F2, that is 3 Newton. This is tail to head vector addition. Now we're gonna find the resultant vector. As I told you, resultant vector is a single vector which drawn from the tail of the first vector to head of the second vector. This is your resultant vector. Take your ruler and measure this. You will get the value. You will get the value 50 millimeters or 5 centimeters. Then you have to convert that into Newton, because the question is find the resultant vector of F1 is equal to 2 Newton and F2 equals 3 Newton. The question doesn't have centimeters or millimeters, so we have to convert. Go back to our scale. 2 Newton equals 20 millimeter, 3 Newton equals 30 millimeters. Then 50 millimeter must be equal to 5 Newton. That's a conversion back to Newton. Then you must write here your FR is 5 Newton. This is simple vector addition using tail to head vector addition.